Hello everybody, this is Mr. Walker. Today's video is how to use a multiplication table to solve division problems. And by multiplication table, we mean something like this. By the end of this video, you will be able to use a multiplication table to find quotients for problems like these. Now, the word quotients refers to the answer to a division problem. So, for example, 45 divided by 5, it said divided by 5, and if you look down, I see 45 right here, and that would be 9 as we go across. Or you could also count in your 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Division is also written this way, 36 divided by 9. So I want to keep an eye on that 9. Here's my 9. I'm going to count down to the 36. 1, 2, 3, 4. So in other words, it would take 4 groups of 9 to get to 36. So the answer is 4. And again, you can see as we sweep across, it would be 4. 18 divided by 2. Here's the 2. I find 2 and I count down to 18, and you can see that that would be 9. "48 divided by 6. I find 6 and I count down to 48. Groups of 6, right? 1, 2, 3, 4, 5, 6, 7, 8. So in other words, 48 divided by 6 equals a quotient of 8. 27 divided by 9. Count down to 27. 1, 2, 3. And the final example, 72 divided by 8. So we're going to go to the factor of 8, or in this case, it would be a divisor of 8, and count down to 72. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in other words, 72 divided by 8 is equal to 9. Any lesson in math will usually have some vocabulary. When we do division, there are some terms for the numbers involved. You would read from left to right as 32 divided by 4 equals 8. The number that you divide is called the dividend, and the number that you're breaking it up to, or the amount of equal groups, is referred to as the divisor. The one I really want you to focus on is the answer, and they refer to that as a quotient. In fact, I'm going to rewrite that. So sometimes you will hear a problem say, what is the quotient? And it'll give you some numbers, and that's your clue that when you're looking for a quotient, that is the answer to a division problem. Also here, when you have a division problem presented this way, this would be read as 32 divided by 4, and your quotient would be 8. And yes, that's a little bit awkward in how you would read that in that circular motion. Remember that when you do division, the key idea is that you want to have equal groups. Or in other words, you would want to have fair share. Here's an example. You could model a division problem using these dots. Or in this case, I'm going to call them cookies. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're starting out with 12. And imagine that you have 12 cookies and you have 4 people that you would want to share that with. Remember, the idea that division is fair share. For example, it's not fair to give 1 cookie to one of the 4 people, 1 cookie to another, 1 cookie to a third, and then all of these would go to the 4th person. That would not be fair. That would not be fair share. So division it requires that the groups be equal. So 12, and we said that for this case, we're going to pretend that it's 4 groups or 4 people. And we could show this by dividing these 12 into 4 equal groups. Notice we have 1, 2, 3, 4. There's your 4. And then our quotient is going to be how many are in each. Well, we can see that that's going to be 1, 2, 3. And there is 3 in every single group. So for this problem, we could say, well, it's 12 cookies, right? Divided equally, because that's what division, it's fair share, 4 ways, which is our 4 right there, would be 3 cookies each. So this would be a proper way to model division because it involves equal groups. Now remember, you don't want to get confused and say, well, I have 12 cookies, green cookies. Ugh, that looks pretty awful, doesn't it? And say, well, I'm going to divide it and I'm going to give one person that and give another person that and give another person this and that. Well, the problem here is what? You did divide it into by 4, but your groups are not equal. Therefore, you cannot do it that way. That would be an improper way. Again, you could do subtraction. We've talked about that in a previous video. You could do a subtraction problem and arrive at some figures, but that would not be division because it is not fair share. So that is an example of how not to try division. Division involves something called inverse facts. I can get my paper straight here. In first grade and second grade, many times they will refer to these as fact families. And for example, and you said, well, what do you mean by that? Well, multiplication and division are referred to as inverse facts, or in other words, like fact families. So for example, 3 times 2 equals 6. I could show that by saying that we have 3 groups, 1, 2, 3, that would be your 3, of 2 each, 1, 2, 1, 2, 1, 2, would be equal to a total of 6. And we could just count that 1, 2, 3, 4, 5, 6. So that would be an example of a multiplication fact. Now we could also take the same thing, which I just kind of drew the same picture down here, and we can use not multiplication, but division. So for example, I'm going to start with 6. 1, 2, 3, 4, 5, 6. And I'm going to divide it by 2. Now remember, we said that it's like a fact family, and you can see there's our 6. And then we said divide by 2. Well, if I were to divide 6 into 2 equal groups, there's one group, there would be 2. Do you notice that we have how many in each group? 1, 2, 3, and 1, 2, 3. That's where we get the 3. So you notice that we are using the same 3 numbers 6, 2, and 3, or you could write them in different orders, 3, 2, and 6, or 2, 3, and 6. And that's what we mean by inverse facts or fact families. You could think of it this way. By the way, inverse facts, sometimes you'll hear the expression inverse operations. Sometimes you hear that. I want you to think of it this way. Imagine that you are here and you have to go from the first floor upstairs to the second floor. I don't know, maybe you have to get some socks or something. And let's just say if when you go upstairs, you go a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps up. Well, when you get your socks, what do you have to do? You have to come back down. Notice when you come back down, you're taking the exact same stairs. So the idea is if it is 10 steps on the way up, right? Then it is going to be what? 10 steps on the way down. And so, well, what does that have to do with division and multiplication? It's kind of a similar idea. When you have multiplication and division, if, for example, 5 times 2 equals 10, well, then 10, which is here, divided by 2, guess what, is going to equal 5. Now, that's important because that's why we can use a multiplication chart to solve division. Because again, that doesn't say division table, that says multiplication table. But because of inverse operations, because of this idea that when you go up 10 stairs, you go down 10 stairs. When you multiply some numbers, and when you divide, it's going to be using the same number. Okay, let's practice some. And it's really helpful for your division facts. Division usually are pretty difficult for a lot of students, and using related multiplication facts is really, really helpful. And again, it's so important, young people, that you learn and memorize your multiplication facts. And a multiplication table really is a great way to do that. Okay, let's try some problems. 64 divided by 8. You see that 8 there? You say, well, is there going to be 64 on this chart? Well, not up here, right? That only goes to 12. But you can see that 8 is right here. And I'm going to look for that 64. And you can see as I count down, it's right here. And that would be a total of 1, 2, 3, 4, 5, 6, 7, 8. So the answer to 64 divided by 8 equals 8. 42 divided by 7. Well, there's your clue, 7. We go to the 7. Let's count down to 42. 1, 2, 3, 4, 5, 6. And again, if you come across, you see the 6. I prefer to keep it simple and count down. However, you could count across. I like to count down. I think it's a little bit easier. So 42 divided by 7 is equal to 6. 50 divided by 5. Here's our 5, and if you count down to 50, you'll notice that we arrive at 10. So in other words, 50 divided by 5 is equal to 10. 24 divided by 3. Here's our 3, and if I count down 1, 2, 3, 4, 5, 6, 7, 8, 24 divided by 3 is equal to 8. 14 divided by 2. Here's my 2. 1, 2, 3, 4, 5, 6. There it is, 7. So 14 divided by 2 is equal to 7. 18 divided by 6. You say, well, 18, no, you're not going to find 18 here, but you will find the 6. Let's count down to 18. 1, 2, 3. Well, that was easy. I like that one. So 18 divided by 6 is equal to 3. "49 divided by 7. So we're going to follow 7. 1, 2, 3, 4, 5, 6. There it is. 7. So 49 divided by 7 is equal to 7. 48 divided by 12. Am I going to find 48 up here? No, but I will find 12. 1, 2, 3, 4. So 48 divided by 12 is equal to 4. 10 divided by 5. Well, in this case, there is a 10, but remember we would prefer to use our divisor, the second number here. So ready? 1, 2. So 10 divided by 5 is equal to 2. Now you say, well, Mr. Walker, couldn't I use the 10? Well, let's try it. If I go to the 10, am I going to count down to the 5? Do you see a 5 here? No. So that's a clue that you need to use they call that the divisor. You would need to use that number, okay? A couple more and we'll be done. 16 divided by 2. Here's our 2. 1, 2, 3, 4, 5, 6, 7, 8. So 16 divided by 2 is equal to 8. One or two more, I promise, I promise. 35 divided by 7. Go to your 7. 1, 2, 3, 4, and there's 35 right there. So that was 5, right? And the last problem. Say the hardest one, right? 99 divided by 11. You're not going to find 99, right? But you will find 11. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 99 divided by 11 equals 9. All right, so let's just do a quick review. If I can find my notes here. Today's lesson again was we're using a multiplication table to help us find basic and solve basic division facts. And we said that multiplication and division are inverse, meaning it's like they're like fact families. So you're able to use a multiplication fact to solve a division fact. Okay, thanks a lot, everybody, and we'll see you next time.